back students to the video lecture series. I am Adil Mansuri from Civil Engineering Department of LJ Institute of Engineering and Technology. So my dear students, in the previous videos we have already covered certain water treatment units such as screening, aeration, clariflocculation, then rapid mixing, right? Now today we are going to start with another unit. The name of the unit is filtration. Okay, so the process name is filtration. Now we have done certain units earlier, right? So even after doing those treatment, water contains suspended particles, microorganisms, as well as color, right? Now to remove these impurities, still further and to produce potable and palatable water, the water is filtered through the beds of granular materials like sand and gravel. Okay, so talking about the definition of the filtration, the process of passing the water through the beds of such granular material is known as filtration. Okay, talking about the filter media, there are three different filter media. That is, first one is sand, second one is gravel, and third one is known as other materials which are used. So talking about sand, the filter sand should generally be obtained from rocks like quartzite and should have different properties. Such properties include it should be free from dirt or other impurities, right? Or it should be of uniform size and nature. Then it should be hard and resistant, right? And if you place sand in hydrochloric acid for 24 hours, then it should not lose more than 5% of its weight. Okay. Now, talking about gravel, the sand beds are supported on the gravel bed. Okay, so the layer of the filter is like first topmost layer will be of sand, then beneath the sand layer that will be of gravel layer. Okay, so the sand beds are supported on the gravel bed, right? And the gravels used should be hard, durable, free from impurities, properly rounded, and should have a density of around 1600 kg per meter cube. Okay, and the gravel which is usually placed in 5 to 6 meters, having finest size on the top. Okay, so as you go from top to bottom, the gravel size will become coarser. Okay, now talking about the other materials, then different materials such as anthracite, garnet sand, or local materials like shredded coconut husk or burned rice husk, right, or metallic ores can also be used in case of filter media. Clear? Let's move ahead. So as you can see on the screen, this is the filter. Okay, so you can see that there are above there are two water troughs, right? So that water will enter into those filter via troughs. Okay, then beneath the troughs there is a sand layer. Okay, and below the sand layer there is a gravel layer, right? That is, they are granularly graded. Okay, and when and we already know that when the water passes through different layers, the water gets purified, right? So here also the same phenomena is acting, right? So when the water passes through sand layer and gravel layer, then below the gravel layer there is a system of manifold and perforated pipes, right? So there are perforated laterals from where the purified water, clean water will be entering the cast iron manifold. Okay, and the purified water will then be sent to the community. Okay, let's move ahead. So let's talk about the types of filters. Okay, so basically there are two types of filters. First one is known as slow sand filter, and second one is known as the rapid sand filter. Rapid sand filter are further classified into rapid sand gravity filter and pressure filter. Okay, now the difference between these type of filters lie mainly in four different criteria. First one is the head required for filtration, right? That is the height required for filtration. Then rate of filtration, that is how much quantity of filtered water is required per hour. Okay, then composition of filter media, as I said, that the first layer will be of sand, then below it will be graded gravels, right? And with the increasing depth, the size of gravel will go on increasing, right? And lastly, that is the method and frequency of cleaning the filter media, right? The reason why we need to keep on cleaning the filter media is that the water will be containing certain kinds of impurities, dust or silt or clay, right? And when it will be passing through different layers, the pores between the layers will get clogged, right? So we need to clean the filter media. Okay, so there are different methods employed for cleaning the filter media as well. Let's now move ahead with the slow sand filter. Okay, so on the screen you can see the slow sand filter, right? They are called slow sand filter because the rate of filtration through them is about 1/20th, right? That is 20th part of the rate of filtration that is happening through the rapid sand filter. Okay, now due to low filtration rate, slow filters requires larger area of land and they are quite costly to install. Okay, now they are also very expensive to operate due to laborious method of bed cleaning by surface scraping. Okay, so in case of slow sand filter, the topmost layer gets clogged, right? So it is known as surface scraping, that is removal of the topmost layer. Okay, so that is also quite a laborious and a costly method. Now, due to that phenomena, slow sand filters are now commonly not used these days, but slow sand filters normally utilize effluent from plain sedimentation tank and are used for relatively clearer water. Okay, so usually those water which have very less quantity of impurities present in water, and and if we need to purify that water, then we can use slow sand filter. Okay, so as you can see in the picture, here on the left hand side you can see it is break pressure chamber, right? So water will enter into this particular chamber and its pressure will be reduced to zero, right? Then it will cross the weir and it will enter the filter media, right? So you can see at the bottom, right? That is at the bottom there is under drains, right? That is perforations. Above it, it is a gravel, and above it, it is sand, and above that is the water. Okay, so when the water will pass through the sand layers and gravel layers, and then into the under drains, okay, and from there it will be taken to the this supply system. Okay, now let's talk about components of a slow sand filter. Okay, so uh, as you can see, the components of slow sand filter includes enclosure tank, filter media, base material, under drainage system, inlet and outlet arrangement, and other appurtenances. Let's talk about the enclosure tank. So it consists of an open watertight rectangular tank which is made up of concrete or masonry, right? And the bed slope is kept around 1 in 100 to 1 in 200. Right now, the depth of the tank usually keeps on varying from 2.5 to 4 meter. The plan area of the tank may vary from 100 to 200 square meters or even more. Now, it depends on the quantity of the water to be treated. Clear? Next, talking about the filter media. The filtering media consists of sand layers about 90 to 110 centimeters in depth. Okay, and they are placed over gravel support as discussed earlier. Now, the effective size of sand usually varies from zero point 0.2 to 0.35 mm, and uniformity coefficient varies from 2 to 3. Okay, finer is the sand, better is the quality of water obtained. The sand may be of same size or graded, right? That is coarse at bottom and finer at the top. Let's talk about base material. So the filter media is supported on base material consisting of 30 to 75 mm sorry 30 to 75 centimeter thick, right, gravels. So and they are of different sizes which are placed in different layers. Now generally 3 to 4 layers each of 15 to 20 centimeter depth are used, and coarsest gravel at the bottom and the finest at the top as indicated in the figure. Okay, you can see that larger size gravels are placed at the bottom and finer are the placed at the top. Clear? Let's talk about under drainage system. You can see the plan of the under drainage system, right? So it consists of a central drain. You can see the central drain, right? And lateral drains are on the either side of the central drains. Clear? So the lateral drains are either earthware pipes or perforated pipes of 7.5 to 10 centimeter in diameter, and they are usually placed at a distance of 2 to 3 meters center to center, and they are sloping towards the center. Okay, now filtered water is collected in first laterals, right, and then from lateral it goes into the central drain, right, and then this filtered water is then passed on to the filter water well, where the after disinfection it can be sent to the community. Talking about inlet and outlet arrangement, an inlet chamber is constructed for admitting the effluent from the plain sedimentation tank without disturbing the layers of the sand of the filter media, and to distribute it uniformly over the filter bed. Okay. Now, a filtered water well is also constructed on the outer side in order to collect the filtered water coming out of the main drain. Inlets and outlets are generally governed by valves. Okay. Talking about other appurtenances which are used in these filters, various appurtenances include measuring of head loss, right? Then controlling depth of water above the filter media, then maintaining constant rate of flow through filter, right? So these are the different devices used for efficient working. Okay. Now the biggest disadvantage of slow sand filter is that it requires large area due to its lower filtration rate, and this requirement makes it uneconomical for places where land is very costly, particularly in congested cities. Okay. Now, in order to reduce the requirement of space and to increase the rate of filtration, a lot of research was conducted, which finally came out with the rapid sand filters, or sometimes we also call it as mechanical sand filters. Okay, so let's talk about rapid sand filters. So again, rapid sand filters are of two types. First one is known as rapid sand gravity filters, and second one is known as pressure filters. So rapid sand filters were first developed in last decade of 19th century, right? And on an average, these filters may yield as high as 30 times the yield given by the slow sand filters. Now, these filters employ coarser sand with effective size of around 0.5 mm, and water from the coagulation sedimentation tanks are used in this filter. Okay, whereas in slow sand filter we cannot use because it will contain high quantity of impurities. Okay, so rapid sand filters are the one which utilizes comparatively larger sized sand particles, which allow greater rate of filtration as compared to the that of the slow sand filter, right? And they are called as rapid sand gravity filters or rapid filters. The second one, talking about the pressure filters, they are the one which utilizes the development of pressure over the filtering water and thereby increasing the rate of filtration. Clear? Let's move ahead. Talking about the components of rapid sand filter. Okay, so this is the picture of a rapid sand filter. You can see, right? Now, talking about the components. First one will be the enclosure tank, then there will be filter media, then there will be base material, then there will be under drainage system and other appurtenances. Okay, so the enclosure tank is made up of masonry or concrete, right? And its depth is usually of 2.5 to 3.5 meter, and surface area is of around 10 to 50 meters square, and length to width ratio is usually 1.25 to 1.35 to 1. Okay, now talking about the filter media. So as we all know that filter media will consist of sand layers, and the depth of sand layers will be of 60 to 90 centimeter. Size of sand will be of 0.35 to 0.6 mm, and number of filters can be obtained using the equation n, that will be equals to square root of q, that is the quantity of discharge or quantity of water required for filtration per hour, right, divided by 4.69. Next, talking about the base material, it has 4 to 5 layers of gravel of depth 45 to 60 centimeter, and it helps to support the sand layers and also distribute water. Under drainage system, if I talk about, then it collects filter water uniformly, distributes backwash water without disturbing the gravel bed, and direction of flow is opposite to that of the backwashing. Okay, so if I talk about the water flow direction, then the water will first enter the sand layers, then gravel layers, then it will enter into the perforations, right? Then into the laterals, then into the manifold, and then the outlet. Okay. So let's move ahead with the working of rapid sand filter. Okay, so as you can see in the picture, this is the cross section of the rapid sand filter. There are total 6 valves in this filter. Valve A for allowing water to enter into the filter, valve B for removing filtered water, valve D and valve C for removing impure water after backwashing, valve E for allowing water to enter for backwashing, and valve F for allowing compressed air. Okay, so what will happen now is, once we need to operate the rapid sand filter, then water from the sedimentation tank or clarifier is allowed to enter into the chamber or filter through valve A. During that time, all the valve D, B, C, D, E or F, all except A will be closed. Okay, only valve A will be open. So as we know that water will enter into this chamber with a higher velocity, so in this particular inlet chamber, the pressure will be released. Okay, so it will become still. So after that, what will happen, the water will slightly, when it will rise, it will come into these beds, okay, where there is a sand and the gravel layer. Okay, so what will happen is, once the water is filled up to the level of filtering, right? Once it is filled up to the level of filtering, valve A is closed and valve B is kept open. Okay, so what will happen is, when the water is allowed to rest for the entire day, right, water will pass through sand layers and gravel layers, through which the water will enter into lateral drains and into the manifold, and it will be released from valve B into the clear water sump or storage tank. Clear? Now this process occurs till the sufficient head is obtained. Okay, that is permissible head. So when the process is started, the head will be quite low. Okay, but when the time proceeds, what will happen is, the sand and the gravel, the voids between the sand and gravels will get clogged, hence the rate of filtration will reduce. As a result, head will increase. Okay, so what will happen is, we will stop the procedure, and in after stopping, what will happen is we will close valve A, we will close valve B. Okay, so right now all the valves are closed. Fine. So whatever the water is there, right, what we will do next is we will open valve F for allowing compressed air, where it is supplied at 1.25 to 1.5 meter cube per minute per meter square of area for 5 minutes, 4 to 5 minutes. Okay, so what will happen, compressed air is passed in the opposite direction, so the gravels and the sand, the whatever the voids between gravel and sand will be there, which were packed, which were filled up, they will get released. Okay, so they will get loose. Okay, and after 5 minutes the valve F is also closed, and wash water from valve E is allowed to enter into the rapid sand filter in the opposite direction. Okay, so all those dirt, silt, clay, whatever was clogged, that will be removed along with the water, right? And that will be removed from here only. Okay, so it will be removed from this valve D as well as from this valve C. B is closed, but C is open, so it will be removed from D and C. Okay. This procedure of washing of filter is done till the clear water starts to appear from this side. Okay, when the clear water starts appearing, we close the procedure of this back washing. Okay, and again the filter will start to act as filtration. Fine. So this is how the filter rapid sand filter works. So let's move ahead. Let's talk about the difference between rapid sand filter and slow sand filter. So as you can see that there are different parameters and different criteria. So talking about the filtration rate, slow sand filter will have about 100 to 200 liter per hour per meter square of area, and rapid sand filters will have 3 to 6,000 liters per hour per meter square. Head loss in slow sand filter will be 15 to 100 centimeter, whereas in case of rapid sand filter it will be 30 centimeter to 3 meter. Talking about area, as we know, slow sand filter will require larger area and rapid sand filters will require smaller area. Filter media, talking about sand, then they will be using size of 0.2 to 0.35 mm for slow sand, and depth will be of 90 to 110 centimeter. And in case of rapid sand filter, size will be of 0.35 to 0.6 mm, depth will be of 60 to 90 centimeter. Similarly, in the case of gravel, the sizes will be 3 to 65 mm, and depth of gravel will be 30 to 75 mm for slow sand, and size will be for 3 to 40 mm for rapid sand filter with a depth of 40 to 65. Coagulation is not required in case of slow sand filter, whereas in case of rapid sand filter, coagulation will be required. Further method of cleaning, in slow sand filter it is scraping of the top layer, and in case of rapid sand filter it is back washing. Period of cleaning includes 1 to 2 months for slow sand filter, and in case of rapid sand filter it is 1 to 2 days. Then talking about the cost, high initial cost for slow sand filter, and rapid sand filter have low cost, and skilled laborers are not required in case of slow sand filter, but it is required in case of rapid sand filter. Okay, so moving further, let's talk about the design steps of RSF. Usually only part 1 is asked. So part 1 includes design of filter beds, that are the number and the size of beds required. So first step will be you have to assume the filtered water to be used for backwashing, that is 3%. Then you have to assume that 30 minutes of time will be lost every day in backwashing of the filter, right? That is, if you are allowing for filtration for 24 hours, then out of 24 hours 30 minutes will be used for backwashing of the filter media. So effective time will be 23.5 hours. Further, you have to assume rate of filtration 5,000 liter per hour per meter square. Usually the rate of filtration between 3 to 6,000. Then we have to find the design discharge in liter per hour. Then step 2 includes find area of filter, that is discharge per rate of filtration. Then we have to find the number of filter beds. You can find out with this formula, that is under root of q by 4.69, where q will be in meter cube per hour. Then further assume length to width ratio. It will be 1.3:1. You can assume between 1.25 to 1.35:1. Then you have to find the length and width and provide total number of filter beds. So after you are getting n, you have to provide one more for standby condition. Okay, so total number will be n plus 1. Further, part 2 includes design of under drainage system. That's quite tricky and tedious. So it includes assumptions. First one will be total area of perforations, that is 0.3% of area of filter bed. Then diameter of perforations, you have to assume 12 mm, right? You can assume in between 6 to 18. Then total area of laterals, twice the area of perforations. Total area of manifold, right, that is the central pipe, bigger one, will be twice that of the laterals. Spacing of between laterals will be of 15 centimeters center to center. Then we have to find out the area of perforations, then find out the area of laterals, then again find out the area of manifold, right? Then find out the diameter of manifold from the area, right? That is pi by 4 d square by 4. And then number of spacing on each side, how much spacing is required. So that will be of length of tank divided by spacing between the laterals, right? Next, step 7 includes the total number of laterals on each side, that will be n minus 1. Then step 8 will be total number of laterals on both the sides, 2 into n minus 1. Then find length of each lateral, that is equals to width of filter by minus diameter of manifold by 2. Then we have to find out area of each perforations, pi by 4 d square by 4, where diameter we have assumed as 12 mm. And find the number of perforations required. So total area of perforations by area of each perforations, and find number of perforations per lateral. So total number of perforations by total number of laterals. 13th step, that is the find out area of each lateral, right? This is quite confusing, but once you will solve on your own, then only you will be able to get proper understanding. So area of each lateral will be total area of laterals by number of laterals, and finally find out diameter of each lateral from the area. And the last step, we have to write that provide so and so diameter of manifold with so and so diameter of laterals having the length of so and so mm or centimeter each with so and so number of perforations of 12 mm diameter. Okay, so here that's the end of our water treatment units, right? We will discuss some new topics in the next video.